Today we're working on problem 4 of our problem set, and we're going to start off today by estimating the width of the river, which we found on a website to be 231 feet wide, and so we convert that over to 70.41 meters. We are looking for the depth of the model, which we can find relating the depth of the river and the length of the river compared to the width of the model and the depth of the model. Using the information given from our problem set, we looked up on the website and found that the depth of the river to be 1.96 meters. Our problem has a constraint on our model of 1.5 meters wide. We assume that the river is roughly rectangular in shape, so we can use this ratio. And plugging in our numbers, we're going to solve for D. So we have 1.5 meters as our constraint, or our width of our model, 70.41 meters as the width of our river, 1.96 as the width of our river, and we're solving for the model, which we found to be 0.0418 meters. For later use in our problems, we have the area of the river to be 138 meters squared and the area of our model to be 0.0627 meters squared. Moving on to part B, we need to relate our Freud numbers together. So we have the Freud of our river and the Freud number of our model. Using this, we're looking for the velocity of the model, and we need to find the velocity of our river. The length of the model and the length of the river can be equated to the depths, which we found in part A. So, to find the velocity of the river, looking again on the same website we used earlier, we found our flow rate of the river to be 226.53 meters cubed per second. Knowing the area, we can solve for velocity of the river to be 1.642 meters per second. Setting our equation equal to the velocity of the model, we can plug in our numbers, and we find that the velocity for the model to be 0.2405 meters per second. Moving on to part C, we need to find the Reynolds number of our model. We use that using the density of water, the viscosity of the water, the velocity of the model, and the depth or the length of our model. Since we know all these numbers from part A and part B, we can plug this into our equation and find that our Reynolds number is going to be 6,607.5. To answer the question, yes, this would be sufficient if the flow remained turbulent in the model. Since our Reynolds number is greater than 500, our flow is to be considered turbulent. And that is how we do problem 4.